One other nice feature of spectrogram tilde is the ability to take these an analyzed spectrogram and save it in a variety from full resolution to any other resolution um, as a PNG file. And it does it pretty quickly and gives you some pretty cool results that mirror what you see here in the visual object. So initially, if we just write, I've got details about doing this in the reference file and also in this behavior tab. We can save the spectrogram. We give it optional arguments of width, height, and DPI, which will open a file chooser because we didn't provide the file name. Or we can add file name, width, height, and DPI, or we can remove the DPI. These would be the defaults. By default, the width will be the number of FFT windows, the frames, and the height is the number of bins, and the DPI is 72. Providing a width or a height of 0 or less than 0 will fall back to full resolution. So we can do a bunch of stuff here. So what does full resolution mean? In this case, it may not be what you want. This is a 48K beluga whale recording, and it's pretty long. And if I save it full resolution, each frame, each window, and each bin within each window is going to be a pixel. So we're going to get it a very wide, kind of short image that's a really high resolution. Let me save that to a file, call it full res. And let's take a look at that real quick. So it saved the spectrogram. It looks different than what we see in the object because we're saving 1 pixel per bin, per frame or window. And so it looks small, it looks wide and short, but it's very high resolution. It's just a different aspect ratio because we're seeing every little bit of data without any overlap, and the object is not doing any averaging of bins together visually, taking the maximum magnitude and so on, which is what I do. Okay, so that's a full resolution one. Let's take the same one. Let's maybe want to get something a little bit. See, this looks a little different because we're rendering multiple bins in a pixel and taking the, in this case, the maximum magnitude of the bins and rendering it. If I specify, let's say, 4,000 by 2,000, it's now going to save a PNG at 4,000 by 2,000. I'm not even worrying about DPI, but you could change that as well. And then let's do another one of 1,000 by 500. And that should be enough to get the point. So full res, we already looked at. That is this guy that I've zoomed in on. If I zoom way out, we can see that it's narrow, or it's long and short. Here's 4,000 by 2,000 pixels. Now we see the whole spectrogram. Still, it looks a little bit more like it does in the object because we're rendering. We're rendering multiple pixels. I'm sorry, multiple bins and frames within 1 pixel. So you get a different look, very pretty. And then if we look at 1,000 by 500, it's gonna look similar, but even be a little bit lower resolution. So you can change. Let me just do one more and change the resolution to, let's say, 1,000 by 100. So it's going to be wide and short. For some reason, maybe I want that. And now we've got this. So the pixel resolution of the PNG is definable. The object will render it to a surface. It render it in the same way that it renders to the object based on how I shrink and grow it. So it's really kind of mirror functionality, but lets you save to a variable resolution PNG file.